Soil-phase relationship. For today's discussion, we will be discussing about weight-volume relationship, mass-volume relationship, and relative density. So guys, I separated the video for the concept discussion and for the problem solving. So this one is for the concept discussion first. So let's start with the first topic, which is the weight-volume relationship. So everything that you will see in this section will be about the derivation of formula relating the weight and volume. Partially saturated soil, it is composed of solids or soil particles, liquids, which is usually water, and gases, usually air. And the spaces between the solids are called voids. Kumbaga, sa concrete, parang siya yung ampaw. Okay? So, the soil water is commonly called pore water. Okay? And it plays a very important role in the behavior of soils under load. If all voids are filled with water, the soil is saturated. Yun nga, two-phase. Bakit siya two-phase? Kasi it has soil and it has water. Otherwise, no, if not, then the soil is unsaturated. Okay? If all the voids are filled with air, the soil is said to be dry. Okay? Or that is two-phase kasi may air saka may soil solids. This is a sample illustration. Figure 3.1a is, yun nga, the soil element in natural state. Then figure 3.1b, three phases of the soil element. So, if you try to look at the natural state of a soil, no, parang, ayan siya. It is composed of voids to be filled with air as well as water, right? But if you try to segmentize or to compartmentalize them, we can divide them into three layers or into three segments, which are, of course, on top is the air, and then the water, and then the soil solids. Of course, this is the soil itself. This is the soil, right? But it is a three-phase element. So it contains, ayun nga, air, water, and soil solids. Ayan, yung mga solids na yan. Now, let us clearly indicate, since we are dealing with weight-volume relationship, so all the parameters that you will see here ay pertaining sa weight and volume. So, let's say that the left side of your figure B is all about the weight. And as you can see, the total weight of the soil is composed of the weight of the water plus the weight of the soil solids. Now, you will ask me, bakit walang weight ng air? Because the weight of the air is actually negligible. Now, we all know that super gaan ng air. Kaya, we don't actually consider the weight of the air. That's why the total weight of the soil is due to the weight of the water lang plus weight ng soil solids. Now, let us look at the right side of your illustration, which is clearly no pure volume. Now, may volume ang air. Okay? May volume din ng water. At of course, may volume yung soil solids. And take note that we call air and water as your voids. Okay? Volume voids. Later on, i-define natin kung ano yung mga ibig sabihin ng mga variables na yan. But, ayun. So, air and water comprises your voids. Sila kasi yung nag-fill sa empty spaces between the soil particles. Kasi, di ba, soil particles are of irregular shape. So, when you try to compact them or to put them, let's say, in one container, though they look compacted externally, but inside of the soil particle, may mga empty spaces dyan. Right? Which is, yun yung voids. And the voids are being filled with air and water. Kaya yun yung total voids. And of course, we have the volume of the soil solids. Okay, so if you try to add volume of air, volume of water, volume of soil solids, you'll get the total volume of the soil. So now, let us derive the needed formula. Kasi ito yung pinaka-basic concept ng soil engineering or ng geotechnical engineering. We cannot proceed with the other succeeding topics if hindi nyo to maintindihan ng mabuti. So as you can see here, figure 3.1a shows an element of soil of volume V and weight W, as it would exist in a natural state. To develop the weight-volume relationships, we must separate the three phases, right? As we did earlier. Thus, the total volume of a given soil can be expressed in this equation. That total volume, or V, comprises the volume of the solid or soil solid plus the volume of the voids. Again, volume of the voids is volume air plus volume of water. So, ayun siya. Again, total volume is volume of soil solids plus volume water plus volume of the air. So now, assuming that the weight of the air is negligible nga, as we said earlier, we can give the total weight of the sample as W, or total weight of the soil, is equal to weight of the soil solids plus weight of water. Okay, and take note that the volume relationships commonly used for the three phases in a soil element are void ratio, okay, porosity. So, pardon me with this one, hindi ko siya naibaba. Then, the third is degree of saturation. And now, let us define each. Void ratio, or symbolized as E, is the ratio of the volume of the voids to the volume of the soil solids. Please remember this. Isa puso nyo to kasi dito manggagaling lahat ng formula later on. Now, what is porosity? Porosity is symbolized as N. Okay, so what is the porosity naman? No? Porosity is defined as the ratio of the volume of voids to the total volume. If void ratio is volume voids over volume of soil solids lang, mas malawak si porosity. Mas malaki yung sakop niya kasi with respect siya sa buong volume. So, volume voids over the total volume or the volume of the soil itself. Next is the degree of saturation, symbolized as S, capital S, no? It is defined naman as the ratio of the volume of water to the volume of voids. Okay, and now let us substitute them simultaneously. So, from this equation, no? So, we have this, right? And then, copy mo lang yung numerator and then, saan galing tong V minus VV? We know that volume of the soil is volume of voids plus volume of the soil solids, right? Now, if you try to get the volume of soil solids, like this one, you'll get V minus VP. So, dun galing to. And then, just to simply, manipulate the equation, i-divide natin itong numerator ng V. So, dapat i-divide mo din yung denominator ng V. Lalabas na equal lang siya sa 1. So, it won't have any effect dun sa equation mo. We have here the volume voids over volume, V. Then, this becomes 1 kasi pag dinivide mo yan sa V, 1 na yan. Then, ito pag dinivide mo sa V, ito kalalabasan. Right? And, from there, we learned a while ago that volume voids over the volume of the soil is the porosity. So, replace it by N. 1 minus, this is also N. That's why you'll have the formula for void ratio. Bukod dito sa formula na to, we can also say that the void ratio is equal to N over 1 minus N. Or, if you try to manipulate this one, diba, alam nyo naman mag-transpose, mag-cross-multiply, you'll come up with this one. huwag nyo nang kabisaduhin to pareho. I suggest, isa lang dyan. Ito na lang. Kasi pag alam mo to, alam mo na rin to para makabawas sa i-memorize. Okay, so the common terms used for weight relationships are moisture content and unit weight. Okay? So guys, ang ginagamit na symbol for moisture content is omega. Omega, mukha siyang W. Sa ibang books, W siya, pero omega talaga siya. It's a Greek letter, no? Unit weight is of course gamma. Then moisture content is omega. Now, how can we define moisture content or omega? Take note that moisture content is also known as water content. Moisture content omega is the ratio of the weight of the water with respect to the weight of the soil solids. Clear? Okay. Tandaan nyo yan, no? That's an important formula, no? Then, unit weight, of course, we all know this one, no? That unit weight is simply the weight over volume. So, if you want to get the unit weight of the soil itself, weight ng soil over volume ng soil. Uy, okay lang doon? Okay? Then, from the previous equations, ganun sa ginawa natin kanina, di ba? Pinagsama-sama natin yung, if you can remember a while ago, pinagsama-sama mo lang yung formula na to, ito, di ba? Kaya nag-come up ka dito sa last formula na to. And then, same goes with this one. Okay? So, from gamma is equal to weight over volume. Ayun. Si weight, saan ba equal si weight? Ano nga ulit ang weight? Kanina, in-introduce ko, di ba? The weight is equal to weight of the soil solids plus weight of water. Bakit walang weight ng air? Since negligible. So, we can replace W by WS plus WW. Right? And then, we can now replace, okay, or we can, okay guys, so for this one, as you can see here, di ba kanina nag-manipulate lang tayo, if you can remember, wait, dito, di ba para lang ma-simplify yung equation, dinivide mo yung numerator and denominator by V, right? So, for the purpose of deriving the formula again, dito, ano ginawa? Para ma-manipulate yung equation. So, from this one, simple lang, no? Pinakomplikado niya lang. Ang ginawa niya, di ba? From WS plus weight water, ang ginawa, nilabas yung WS. Kaya matitira dito 1. Para pag WS times 1, WS pa din. Okay, tas dito, ginawa, WW over WS. O pag kinross or pag minultiply mo yung WS kay WW over WS, magka-cancel lang to. Babalik ka lang doon sa WS plus WW. So, dun siya galing, okay? And then over V. Okay guys, just an additional trivia. This one here is also referred sometimes as moist unit weight. Often, to solve earthwork problems, one must know the weight per unit volume of soil, excluding water. And that this weight is referred as the dry unit weight. So, pag dry unit weight, wala siyang water. Kaya, knowing that unit weight is weight over volume, let's clearly define what is gamma dry. Gamma dry or dry unit weight is weight ng soil solids. As you can see, tinanggal yung water kasi yung air naman ay walang weight, diba? Kumbaga, tinanggal yung water kaya dry siya, no? Over the total volume or the volume of the soil. And then from the previous equations kanina, no, we can say that gamma dry is also equal to gamma over 1 plus omega. So how come? Bakit nangyari yan? So, we will simply replace the volume here by, okay, and then from here, what is V? Tama ba? V is, okay, 1 plus omega all over gamma. Now, you'll simply replace the denominator by this one. So it will become okay, and this one will cancel out. And it will become gamma over 1 plus omega. And also guys, sometimes it is convenient to express soil densities in terms of mass densities. And for the density, we know naman, diba, that density is mass over volume. Now, if you want to get the dry density, you remove the water to make it dry. We know that mass, total mass, para lang siyang weight, no? Total weight is weight of water plus weight of soil solids. So is the mass. Mass is mass of water plus mass of the soil solids. Now, if you want to get the dry unit weight, you simply remove the water. So, what remains is the mass of the soil solid lang over the volume. And now, let us get the relationships among unit weight, void ratio, moisture content, and specific gravity. So, as you can see here in the figure 3.2, is the three separate phases of a soil element with volume of soil solids equal to 1. Okay, so we denote the volume of the soil solids equal to 1, and we denote that the weight of the soil solid is GS, or specific gravity of the soil solid, times gamma of water. We defined the volume of water as omega GS, or the water content times the specific gravity of the soil solid. And then we define the weight of the water as omega GS and gamma water. Now, if the volume of the soil solids is equal to 1, then the volume of voids is numerically equal to void ratio, as you can see here. Now, you might ask me, how come? If you can remember a while ago, we learned that the void ratio is the volume of the voids with respect to the volume of the soil solids, right? And if we equate this as 1, therefore, E is just equal to the volume of the voids. We can get the weights of soil solids and water, as you can see here, where GS is the specific gravity of soil solids, omega is the moisture content, gamma W is actually gamma sub W. Using the definitions of unit weight and dry unit weight, we can write gamma is equal to weight over volume. We all know that. And we can replace again the weight of the soil equal to the weight of the soil solids plus weight water over the volume of the soil sample. And we can replace WS by GS gamma water and WW as omega GS gamma water, and then V, or the total volume, is 1 plus E, right? Since volume solid or soil solid is equal to 1, volume voids is E, then the total volume is 1 plus E. Then, we can factor out GS gamma water, leaving 1 plus omega inside the quantity, and we have GS gamma water all over 1 plus E. Of course, we can also get gamma dry, as we learned a while ago. That is weight of the soil solids over the volume of the soil sample, and the weight of the soil solid is GS gamma water all over the total volume, which is 1 plus E. Or we can manipulate this equation. Gamma dry is equal to GS gamma water all over 1 plus E into this one. But guys, this is not that important. It is not that important. You can just ignore this one, but you need to know this concept. So again, I don't recommend na i-memorize nyo pa to. Kita naman siya dito, or madali naman siya ma-derive from this equation. And because the weight of water for the soil element under consideration is omega GS gamma water, the volume occupied by water is VW is equal to weight of the water over gamma of water. How did we come up with this one? Of course, we know that gamma is equal to weight over volume. So to get the gamma of water, that is weight water over volume water. You have volume water is equal to weight water over gamma water. So dun siya galing, guys, okay? Again, we can replace weight of water as omega GS gamma water. That is here. Kinopya ko lang yung figure. And then, gamma water. And since we can cancel out gamma water from the numerator, right? And gamma water from the denominator, we get omega GS. Hence, from the definition of degree of saturation, we discussed that the degree of saturation is the volume of water all over the volume of the voids. So, since volume of water is omega GS and volume of voids is equal to E, therefore, from here, we can derive the equation SE is equal to omega GS. Actually, this one, may acronym siya eh. You can use the acronym SEWIGES. Diyan mukha siyang SEWIGES. So, ako, nung nag-aaral ako nun, yun lang tinandaan ko and hindi ko na siya nakalimutan ever. But take note, this is omega ha. Mukha lang siyang W, kaya SEWIGES yung parang mnemonics. So, gumagamit tayo ng mnemonics sa mga formula na medyo may katunog. Diba? Parang pag binasa mo siya, sounds familiar. Para madali tayong makarecall ng formula. Okay, so let's describe. This equation is useful for solving problems involving three-phase relationships. Kasi guys, if you can see here, na pagsama-sama mo yung three phases natin. Right? Which is the, of course, napagsama-sama mo yung mga formula na na-derive from three phases, the air, water, and the soil solid, no? Kaya siya three-phase relationship yung ini-involve niya. Okay, so let's proceed. Now, let's relate the saturated unit weight with weight and volume. So, we know that the saturated unit weight is simply the weight over volume, right? Because we know that if the soil has air and water, then it is saturated, or even water lang na it is saturated over the volume. So, the weight of the soil sample is weight ng soil solid plus weight of water over the volume, right? And then, we replace this one, diba? Kanina lang din, kinopya mo lang, yan lang din yung kanina, but we came up with this very useful equation. Tandaan nyo, gamit na gamit itong formula na to, that gamma saturated is equal to GS plus E gamma water all over 1 plus E. Madalas mo yan makakasalamuha sa kahit anong subject under geotechnical engineering or kahit anong topic, ma-encounter mo yan. Okay, also, take note, from the previous equation with S is equal to 1, no? Pag saturated, guys, tandaan nyo pagka fully saturated ang soil, ibig sabihin, 100% ang kanyang degree of saturation. Okay, so when it is saturated, if S is equal to 1, ulitin natin yung SEWIGES na formula. If S is equal to 1, then this becomes E na lang. Okay, so again, you don't need to memorize this. Kasi if you know this formula, diba, kahit anong value ng S, baka di-derive mo yung formula. Okay, so next slide. Actually, this is the last slide for our first topic. So, due to the convenience of working with densities in the SI system, mas madali kasi guys yung SI system pagka density eh. So, the following equations will be useful. So, again, we have density is equal to mass over volume, right? Mass over volume, yes. Now, alam niyo na kung saan galing to? So, galing lang siya sa mass over volume. Ito, walang question, bakit siya volume? Kasi 1 plus iyon. And then here, the mass is combined na. Mass ng water plus mass ng soil solids. So, again, guys, we know that mass ng water is, we know that the weight of water is omega GS gamma water, and then the weight of the soil solid is GS gamma water. Now, if we go back here, tama ba? Weight water is omega GS gamma water. Now, if you try to get the mass of the water only, you simply use omega GS raw water. Same with the weight of the soil solid, that is GS gamma water. Therefore, the mass of the soil solid is GS omega water. So again, this is mass over volume. Mass of the soil plus mass of the water over 1 plus E, right? So if we try to replace this by omega GS rho water plus mass of the water GS gamma water, then we can factor out GS. This should be gamma water, I'm sorry. It should be raw water. It should not be gamma water. Raw water. Ito siya. Right? So, from here, we can factor out GS raw water. And what remains inside is 1 or omega plus 1. So, dun siya galing, guys. Nag-gets niyo ba yung point ko? Though, medyo tricky siya, pero ganoon talaga siya na-derive. But don't worry, guys, no? Masasanay din kayo sa pagde-derive. Okay? And then, ayun, for the following or the other formula, gamma dry naman ito. Or sorry, lagi ko nasabing gamma. Raw dry naman ito. So, mangyayari lang, guys, mawawala lang yung water content. Kasi pag dry siya, wala siyang water content. So, GS raw water over 1 plus E lang yan. This one naman, guys, is galing lang din siya sa mass over volume. Again, the mass is comprised of the mass of the water plus the mass of the soil solid. And again, mass of water is omega GS raw water. Mass of the soil solid is GS raw water. And since we know that SE is equal to omega GS and this is 1, therefore this becomes E omega GS, then we can replace this one here. So if that becomes E, let's continue here. We have E raw water plus GS raw water. Then we can factor out raw water giving us GS plus E. Okay. All over the total volume, which is, again, 1 plus E. We know that earlier. So that's it, guys. That's how we use the weight and volume relationship to come up with the following derived formulas. Okay, so stay tuned for our next topic, which is all about mass-volume relationship.